Okay, good evening. Yesterday we were talking about interest rates, especially simple interest, compound interest, and after that we talked a little bit about the notations that we are going to use. Present value is something that we will be using, future value, okay, these terms, then accumulation factor. Future value, we'll also call it as accumulated value. The value that has been accumulated after so many years, we'll call it as accumulated value. Accumulation factor is nothing but our future value is equals to present value into the whatever amount we are talking about, that becomes the accumulated factor. So for simple interest, it was 1 plus I into the time, and for compound interest 1 plus I raised to n. That is what we said accumulation factor is. Now right now let's talk about principle of consistency. So principle of consistency says that the investors investing the same amount for the same time period should earn the same returns irrespective of the path of the investment. Okay. So let's say we have two different investors. One is investing from time 0 to let's say time n, okay, directly for this much time, but the other investor invests from time 0 to then time 1 and then reinvests from time 1 to time n. Okay, so one is directly going from time 0 to time n, the other is going from time 0 to time 1 and then reinvesting from time 1 to time n. We are saying both of these investors should earn the same returns. That is what we are saying. Okay. So irrespective of the path chosen. So we might have a path, something like from time 0 to time 1, then reinvested that money. From time 1 to time 2, then reinvested that money from time 2 to time n. Or we might have time 0 to time 2 and then from time 2 to time n. Irrespective of what path is chosen, we should have the same returns. That is what this principle of consistency says. So we say accumulation factor from time 0 to time n should be equal to accumulation time 0 to time 1 and then time 1 to time n, or it should also be equal to t0 to t1 then going from T1 to T2, and then going from T2 to Tn, or it should also be equal to going from T0 to T2 and then going from T2 to Tn, irrespective of path taken. If we are going from time 1 to time 0 to time n, then the return should be the same. That means our accumulation factors will also be same. Okay, this is what principle of consistency says. Okay, so everybody understood? Some people joined late, so let me know, just read this, what we are saying here. We are saying irrespective of the path taken of the investment, the returns should be same. That is why accumulation, if directly gone from time 0 to time n, should be same as if we are going from time 0 to time 1 and then reinvesting from time 1 to time n. This kind of every different path that you can make should have the same returns. Okay, so let me know if there is any problem. Okay, so I'll take an example from the book. Okay, so here's the question. If you want to write, this is page number 9 question. Okay. So whenever we are writing a book question, refer to the page number of the question, page number 9 question. Okay. So we have 4,600 is invested at time 0 and the proceeds at time 10 are 8,200. Calculate the accumulation factor from 7 to 10 if accumulation factors these are given. So first thing we'll do is we will just mark down what are the accumulation factors that are given to us. Okay. So we are going from 0 to 10. Okay. So we have 2, 4, 7 and 9. These are the times that have been given in between. Don't worry about the scale of it. Does not matter if 2 and 0 to 2 and 2 to 4 are not matching the other times and stuff. Don't worry about it. These are the times that we require in between. Now they have given you accumulation factor from 0 to 9. I'll mark that down. I'll say 0 to 9 is given to me. Then 2 to 4 is given to me. Mark that down here. 2 to 7 is given, and 4 to 9 is given. We have to calculate 7 to 10. This is what we have to calculate. I'll mark it up. This is what we have to calculate. And there is the first statement that we can use to calculate the accumulation factor from 0 to 10. Now, if you see in this question, there is no interest rate given. They did not say simple interest, they did not say compound interest, they did not say 7%, they did not say 10%. When we have the accumulation factor, we don't really need the rate of interest. Accumulation factor tells us by how much will it increase, will the amount be increased if we invest for this much time. Okay, so it does not matter what the interest rate is here, we can solve this without knowing the interest rates. So from the first statement, I can say that the present value must be this 4,600 that was invested at time 0 and proceeds at time 10. That means future value at time 10 is 8,200. And because we have all the question just has the accumulation factors, we are not worried about the interest rates. So I'll use this equation to solve it and find accumulation factor from 0 to 10. Okay, so I can say future value at time 10 will be equal to present value into accumulation factor from 0 to 10. So we are going from 0 to time 10. We have 1.7826. When you buy the physical calculator, you will find that most of the times the answers are given in fractions. Okay, so the answers would be given like this, 41/23. If you want to convert the answer from fraction to decimal, we have this key, this button here, SD. Okay, you can see just above del. We'll press that button and it will convert a answer from fraction to decimal. If I press that again, it will convert from decimal to fractions. Okay, so after calculating this, we also have 0 to 10. So now the lines that I have drawn below are all the values that we know, and the above is what we are trying to find. Okay, so I can say that if I want to find this 7 to 10, only one of these lines contains that 7 to 10. So I can say accumulation factor from 0 to 10 can be written as accumulation factor from 0 to 7 multiplied by accumulation factor 7 to 10. Remember, the accumulation factors will always get multiplied. So we'll go from 0 to 7, then from 7 to 10. Okay. Now I don't have a value directly 0 to 7. I need to find this 7 to 10. I have this 0 to 10, but I don't have directly 0 to 7. So what I can do is I can split that 0 to 7 in multiple parts again. Okay. So I have 2 to 7. I have this value directly. So what I can do is I can split that and say this is nothing but accumulation 0 to 2, accumulation 2 to 7, accumulation 7 to 10. So again we have this 2 to 7, but we do not have 0 to 2. Okay. I do not have 0 to 2 directly, and I will not be able to split them. But what I can do is I can find that in some other manner. If you see, if I have 0 to 9, if you see 0 to 9, we do have that already. Okay. We can split that into 0 to 2, then 2 to 4, and then 4 to 9. We can split that in this manner. You can see the lines below. Right. So using that, I will be calculating 0 to 2. So accumulation 0 to 9 can be written as accumulation 0 to 2 into accumulation 2 to 4, right? 0 to 2, 2 to 4, and 4 to 9. Yes. 2 to 4, and then accumulation 4 to 9. So accumulation 0 to 2 will be nothing but accumulation 0 to 9 upon 2 to 4, 4 to 9. Let's take that values from the question. Okay. So 0 to 9 is given as 1.8 upon 2 to 4 is 1.1, and then 4 to 9 is 1.45. So now I have 0 to 2 as well. So the only unknown in this equation is 7 to 10. We'll say accumulation 7 to 10 will be equal to accumulation 0 to 10 divided by 0 to 2, 2 to 7. Again we'll look up the question. 7 to 10 was, we found out here. 0 to 2 also we know 1.12853. 2 to 7 we'll look up in the question. 2 to 7 was 1.32. Now in our calculator there is an answer key. You can see here answer button. Okay. Now you can use that for taking the previous equation's answer. So in the previous equation we calculated this value, so I can use it as answer. Answer into 1.32. So this is our answer. Accumulation 7 to 10 would be 1.1967. Any problem in this? At any point if you feel like you did not understand something, let me know. I'll explain it again. Chalo. So let's move forward. So I hope you understand what principle of consistency is, and we can use that to find such missing accumulation factors. You can imagine that I can make them in terms of rate of interest also. Let me make up a question. Okay. All the rate of interest that I am writing are per annum. Now, if I did not mention whether it is compound or whether it is simple or compound, we will always assume it is compound. But let's say if the rates are first compound and second simple. Okay, so we'll solve for both because we need to understand what's happening here. Okay, so first we'll solve for compound interest and then we'll solve for simple interest. So what I have done is from 0 to 10 we know the rate of interest is 7%. I'll say 7% from 0 to 10, it is 7%. Okay, and then 0 to 5 is what we have to find. 5 to 7 is given. 5 to 7 is 6.25%, and then 7 to 10 is 8%. Okay, these are the rates of interest given. We have to find this 0 to 5. Okay, so we'll simply use principle of consistency and we will say accumulation factor from 0 to 10 must be equal to accumulation 0 to 5 into accumulation 5 to 7 into accumulation 7 to 10. This is what we want to find. So we want to find this 0 to 5. So now, irrespective of whether the interest rates were in compound or whether the interest rates were in simple, the principle of consistency will not change. Okay, principle of consistency will not change. Okay. So if my rates of interest were compound, then accumulation factor between any two times, let's say T1 to T2, will be 1 plus I raised to the difference in time. So if I'm going from 0 to 10, it is 10 years. But if I'm going from 5 to 7, it is going to be 2 years, because the time is just 2 years here in between. So I'll say it is T2 minus T1. This is how we will write our accumulation factor. So 1 plus, now rate of interest is given as 7% between 0 and 10. So 1 plus, or you can directly write 1.07. 1.07 raised to 10 must be equal to accumulation factor, I'll say 1 plus I raised to 5 into, between 5 and 7 it is 6.25%. So into 1.0625 raised to 2 into yes, Sambhav, you want to ask something?
सर ये T1 T2 equals to 1 plus I, ये वाला क्या लिखा है आपने सर, समझ नहीं आया.
So yesterday, when we were studying accumulation factor, we said that future value is equal to present value into whatever we write here is our accumulation factor. ठीक है? By how much does the value change? That is what our accumulation factor is. So when we have a compound interest, we say this 1 plus I raised to n is our accumulation factor. ठीक है? If we are going from time 0 to time n. So यहाँ पर what we are doing is, this part we are just taking the difference in time, that is the number of years, right? The difference in time would be the number of years. Okay, so that is why 1 plus I, the rate of interest given from 0 to 10 is 7%. Okay. So 1 plus I raised to 10, because the difference in time from 0 to 10 is 10 years. Here this is what we have to find, this I is what we have to find. Okay. 0 to 5. And यहाँ पर, here what do we have? This rate of interest 6.25% is going from time 5 to time 7. Right? Time 5 to time 7. So therefore 7 minus 5, we will have 2 years. Okay, raised to 2 years. This 8% is going from 7 to 10. We have 3 years. So raised to 3. Is that clear?
Yes, sir.
Good. So then 1 plus I raised to 5, or even if, let's say, plus I, I'll have this is what we'll get. Okay, so we can directly find this. We can directly make an equation in our calculator like this. I'll start with a bracket, then I want a fraction. Let's say 1.07 raised to, so raised to is this, raised to 10. Then I'll use navigation keys to come down, so down arrow, and you can see it is down. Okay. And I'll have 1.0625 raised to 2, then side arrow to get it on the side, into 1.08 raised to 3, and then by arrows I'll come on the side, I'll close the brackets, and then raised to, I want 1 by 5, I'll just write 1 divided by 5. Okay. Equal to, so I have 1.06704. so rate of interest I will just be minus 1, so I can directly say minus 1. It will take the previous answer and then subtract 1 to it. So I have 0.6704. So I is 0.06704. Now whenever we are writing interest rate, if you write the answer like this, that is completely fine, but I prefer writing it in percentage because interest rate is mostly given in percentage form. So percentage will just become 6.04%. Okay. So percentage is this. Okay. Second, we want for simple. In simple interest, an accumulation factor from time t1 to t2 will actually be 1 plus the rate of interest into the number of years. The number of years here would be again t2 minus t1. This is what we will have. So again 0 to 10, the rate of interest is 7%. So 1 plus 0.07 into 10 will be equal to 1 plus I into 5. Then into accumulation factors will always get multiplied. Remember that. 1 plus 0.0625 into 2 years. 1 plus 0.08 into 3. So then 1 plus 5I will be equal to, this is going to be 1.7 upon 6 to 5 will be 1 to 5. So upon 1.125 into 8 into 3, 24. So 1.24. So clearly I will be much minus 1 upon 5. So minus 1 is equals to, and then let's say answer divided by 5. So I can again write this in percentage form. So it is 4.373%. Okay. This is how we'll get the rate of interest using the principle of consistency. Now actually simple interest is not consistent. Okay, simple interest is not consistent. So we almost never will use this in real life. Okay, simple interest is not consistent, but they may ask you question because these are just simple questions and they can just complicate that simple interest and compound interest. Okay, but in real life we don't really use the simple interest in principle of consistency. Okay, per annum. Any problem here? we are going to learn another concept, that is rate of discount. Now, whenever I say the word discount, what comes into your mind? First thing that comes into your mind? Can you tell me what comes into your mind? I just say discount. If I just say discount, anyone? What comes into your mind?
Sir, offer or something.
Offer or sale, right? Whenever we say sale, correct? In sale, we find discount offers on products, right? Now, how do we calculate discount? If I say a product is of 1000 rupees and there is a 20% discount, how do we calculate the discount? How do we calculate the actual price? We would just calculate the 20%. So we'll say 20% of 1000 is 200, correct? So that is the discount, and I will subtract that from 1000. I'll say 1000 minus 200 should give me 800. This is my sale price, right? So what we are doing here is we are saying 1000 into 1 minus this rate of discount. Okay, rate of discount D. So this is rate of discount. So why are they giving you rate of discount? Because it is very easy for you to subtract that value from the original price and figure out what the sale price is going to be. Okay. So it becomes very easy for us to do this calculation. Now, we use rate of discount instead of rate of interest. So in many places what happens is you have to figure out what your final value is going to be, what your present value is going to be when the accumulated value is known to you. So let's say that I want to buy a house in next 5 years. So after 5 years I want to buy a house that is, let's say, 5 crore rupees. So I need to put money today in bank account so that I will have 5 crore rupees in 5 years time. So how much money should I put in today so that I have exactly 5 crore rupees in 5 years time, right? So what I need is, I need to find the present value when I know the future value, when I know the accumulated value. Okay. So for such calculations, the rate of discount is easier to use. Okay. Especially when last class also I said that there will always be people working in finance, or at least requiring the finance, who have not even studied mathematics, right? So you have to make easier calculations for them. Okay. So same thing, if I give you discount rate, it will be easier for you to calculate the present value if future value is given to you. So that is the concept of rate of discount. So rate of discount, we will write it in terms of D. Okay. And if I have simple discount, I'll say my present value at time 0 will be equal to, let's say, future value at time n into 1 minus n times D. Okay. And if I'm talking about compound discount, then we'll say present value will be equal to future value at time n into 1 minus D the whole raised to n. So when I'm saying we have to make it easier for people who do not understand mathematics or who have not studied mathematics, for them this will always be easier. Okay, so if I give them the simple rate of discount, they can multiply it with the number of years that we want to calculate this discount for, and then easily calculate what the present value is. And we know that simple interest is used when the amount is less and the time period is also less. Similarly, simple discount will only be used when amount is less and time period is also less. Okay. Okay. So I hope you understand what rate of discount is.
Sir, can you please repeat rate of discount once again?
Okay, so it is very similar to rate of interest. It's a rate that is given to you. Like here in this question, I am saying a bank offers 7% per annum rate of discount. Okay, so how do we do calculation? We go backwards. So here what we are doing, see, in rate of interest, if I write rate of interest, I would have said that future value at time n must be equal to present value at time 0 into 1 plus n times I, right? This is for simple interest. For compound interest, I would have said future value at time n must be equal to present value into 1 plus I the whole raised to n. This is for compound interest, correct? So what we are saying is we are calculating the future value when present value is known to us. For that we are calculating the rate of interest. Now if I ask you how to calculate the present value if future value is known to you, you can easily say that present value will be equal to future value upon 1 plus I raised to n. Of course, this will be perfectly fine, no problem. Okay, no problem here. But you can imagine if I have some amount and I ask you to multiply it with 1.07, you can easily do it. Okay, you will not have a lot of difficulty in doing it. But if I ask you to divide it without a calculator, it will be a little bit difficult, right? So we find that multiplications are a lot easier than divisions. So when these concepts were made, they said let's make a concept of rate of discount that would be easier for people to calculate by just multiplying. Okay, so we created the concept of rate of discount. Now of course, why we are studying it today? Because it is useful later on. Right now I cannot tell you how it will be useful later on. Okay, but it will be very much useful. Right now we just need to understand what this rate of discount does. Okay, so if I have simple rate of discount, I'm saying discounting, like in sale we subtract the discount money from the original price to get the sale price. Same way, from the future value we are going to subtract the discount to get how much present value we have, or how much present value we need to keep today, so that we get the future value um, in whatever years, n years of time. Is that clear?
Okay, sir, understood.
Okay, sure. So a bank offers 7% per annum rate of discount on an account. so bank offers 7% per annum rate of discount on an account. An investor wants to accumulate 15,000 after 8 years. Find the amount invested today in this account to obtain 15,000 after 8 years. Okay, that is what we are trying to find. So again, you can see we are trying to find the amount that should be invested today to obtain 15,000. So 15,000 becomes the future value. So the rate of discount is given as 7%. If nothing is written, we are going to assume it's compound. Then future value is 15,000. N is 8 years. We are finding the present value. So present value we'll say is nothing but 15,000 into 1 minus d the whole raised to 8. Okay, because we are assuming compound interest. Okay. So we can directly do it on the calculator. I'll say 15,000 into bracket 1 minus d was 7%, so 0.07 bracket close raised to 8. So 8,393 must be invested today so that we get 15,000 8 years from now. So it's clear how the discount rate is working. So as I said, although it was conceptualized so that it becomes easier for us to calculate present value, today with a scientific calculator, it is not difficult for us to calculate present value using rate of interest. Okay, that is not a big deal. So we can do the both types of calculations. So we can say that present value is equals to future value into 1 minus d raised to n. I am only writing for okay, I will talk about it later. Okay, chalo, I will first write down one more concept: discounting factor. Okay, discounting factor. So discounting factor is very similar to accumulation factor. That means it is just taking into account the factors and not and ignoring the amounts that we are talking about. Okay, you might say it is the factor by which the future value will decrease to give me the present value. Okay, but the definition would look something like this: the amount of value today invested to accumulate an amount of 1 in t years time. So if I want my future value to be 1, the amount that I am investing today will give me nothing but the discounting factor. We say that present value must be equal to future value at time t, let's say, okay, into Vt. This is nothing but our discounting factor. Okay, so discounting factor Vt is going to be 1 minus d raised to t for compound. Again, t is nothing but time difference. Now we always assume that when we are using discounting factor, we are going to time 0. Okay, we are going to the amount today. In accumulation factor, we had 2 times. We had t1 and t2, going from time t1 going till time t2. But in discounting factor, we have just one time t. So we are going from time t to time 0. And this would be 1 minus t times d for simple. Okay, again it's just a symbol. We will use it sometimes, like we are going to use accumulation factor sometimes. Similarly, we can use discounting factor symbol. And we are going to use small v. This is discounting factor for 1 year. Small v is used as discounting factor for 1 year. We are learning all of these new terms, new symbols, so that it becomes easier for us to make formulas later on. You will find that we use this v a lot, so that we make the formulas shorter, easier to remember, easier to write. Okay, just a symbol. How we will work it out, we'll talk about it as we go along. Now I'll just take examples of compound interest to understand what's going on, so that we can relate to what's going on. Okay, so for accumulation factor, let's say we are going from 0 to n. We said that is nothing but 1 plus I raised to n. Okay, we use that. We'll say the future value at time n will be present value today into accumulation factor 0 to n. Okay, so that was nothing but present value into 1 plus I raised to n. And discounting factor, let's say Vn would be 1 minus d raised to n. Okay, we are going to use that to calculate the present value directly from future value that is given. So future value at time n into Vn, that is nothing but 1 minus d raised to n. Now I can always use accumulation factor to calculate the present value also. I can say that present value will be future value at time n upon accumulation factor 0 to n. I can always use that. Or I can use this discounting factor to calculate future value also. I can say future value at time n will be equal to present value upon Vn. Always we can use that. not a big deal. Because we have scientific calculators, we can do complex calculations, we don't mind dividing, we don't mind having a very odd power, we don't care about those things. We can easily calculate all of these. Right. So if I relate these two, or maybe relate these two, does not matter which one you are relating, you can clearly see that accumulation factor and discounting factor are reciprocals of each other. Okay, I'll say present value right, and here I can say future value at time n is present value into accumulation 0 to n. So clearly accumulation factor and discounting factors are reciprocals of each other. You can say a 0 comma n is equals to 1 by bn. Any problem here? So for compound, interest slash discount, we can convert it from one to the other. We can convert interest rate into discount rate, we can convert discount rate into interest rate. Okay. So we'll say 1 plus I. So again accumulation 0 comma n must be equal to 1 by Vn. So 1 plus I raised to n will be equal to 1 by 1 minus d the whole raised to n. Power n will cancel each other out, and I'll have 1 plus I is equals to 1 by 1 minus d. I must be equal to 1 by 1 minus d minus 1, and therefore I becomes d upon 1 minus d. Okay. Now to find d, I can also say 1 minus d will be equal to 1 by 1 plus I, right? Just taken the reciprocal of this, just taken the reciprocal. So d will be equal to 1 minus of 1 by 1 plus I, and that gives us I upon 1 plus I. Okay. So we can convert rate of interest into rate of discount. We can convert rate of discount into rate of interest. Again, it is going to be very useful when we are making formulas. Right now we just have to learn how can we convert one into the other. Now again we are going to do this only for compound interest. Simple interest we will not be doing because simple interest is not consistent. Let me show you what happens. So So if I take simple interest slash discount, again accumulation 0 to n would be 1 plus I 1 plus n times I, and discounting 1 minus n times d. They are reciprocals of each other. I'll solve it one below the other. So we were able to convert our formula. We can create a formula, but you can see here it is dependent on n. So the conversion will work only for one single time period. So if you are calculating for 5 years, you can convert your discount rate to interest rate or interest rate to discount rate, not a big problem. But you cannot use that conversion then to calculate for 4 years or 10 years or 15 years. But you can do that here. You can see these are independent of n. There is no n here. So for compound rate of interest, compound rate of discount, we can convert at any time period and use it in any time period, because they are independent of any time period. As it is dependent on n, this converted rate can be used only for that time period, and that is why we don't really use the conversions for simple rate of interest and discount. Okay. But these compound rates, you will have to remember them as formulas, because it is very useful. We use them a lot throughout CM1, CM2, every course where we are using interest rates, you will be using these conversion rates. Now before we move forward, there will be a lot of formulas throughout the course. Throughout CM1, we will have a lot of formulas. Okay. Now the IFOA examination as well as IAI examination, both of these examination are closed book examination. That means you cannot keep any book open, you cannot have your own formula sheets, nothing. Okay, it's a closed book examination, so you will have to remember all the formulas. Okay, so what I always suggest is make a formula sheet. Okay, just buy those Fullscape papers, bunch of them. Start writing the formulas chapter wise, however you understand it well. Okay, I can always give you a formula sheet. I have ready, formula sheet is ready, but it will always be better if you make your own formula sheet, because you will understand it better. First of all, you will be going through the whole chapter to understand how the formulas work, and some formulas may not be important for me, but they might be important for you. Okay, so formula sheet is very important. So whatever you feel is an information that is important, start writing in that formula sheet. Okay, and let's say after you have completed 5 chapters, then revise that formula sheet when you are practicing, when you are revising the whole chapters. Again, you should revise your formula sheet, because by that time most of the formulas or most of the concept that you have written, you will remember them. Okay, so then recreate the formula sheets for those chapters. Then again, for the next 5 chapters, you will make a formula sheet. Then after 5 chapters, you will come back again and revise those 5 chapters as well, so that your formula sheet now becomes smaller and smaller, compressed formula sheets. Okay, and by the time of your examination, you will remember most of your formulas very well, because you have done all the revisions, because you have solved them. During your during when you are solving your questions, keep the formula sheets ready with you. Okay, that will help you solve the questions. If you get confused, you can always refer to the formula sheet, it becomes easier, right? So that is why I'm saying have separate formula sheets. Do not write all the formulas in your notebook and then when required turn the pages throughout and search for those formulas. No, that will not work. That will waste a lot of your study time. So create separate formula sheets chapter wise, then keep on revising after a few chapters, so that you remove all the unimportant stuff, and by the end of your course you will have very good formula sheets that you can use for revision. Okay, so very important. Right from today I would like you to make formula sheets. Okay, so that is why this is not a formula, we are not going to be using this, but these are definitely formulas. Just give you a simple example. I'll just write let's use those formulas. So d will be equal to I upon 1 plus I. I'll write it in percentage. Ten percent is 0.1. We'll again write it in percentage form.
Sir,
Yes.
Sir, we can also use one formula for both the questions.
Which formula?
Like, sir, you have written d equal to I upon 1 plus I. We can use this formula for both the questions, right?
Yes, you can rearrange it, but if you remember both the formulas, then it will be easier. Like, you can always rearrange. You'll say di upon 1 plus I, and then d is given, that would be 0.1 is equals to I upon 1 plus I, and you'll have to rearrange. So you can see we got exactly the same thing.
Yes, sir. Understood.
Okay. So this is how we can convert one rate to the other, and we can use them. So as I said, although at the beginning I don't have an explanation for you right now, but you will realize later that having two different rates, interest rate and discount rate, is useful, especially for making formulas and remembering formulas. Okay, so this, I can even make a question. Okay, let's find v. Small v is just discounting factor for 1 year. Okay, I did not make a formula before, but let's make a formula here. So discounting factor for 1 year. So when I say discounting factor for 1 year, that means capital V1 is going to be this small v. That would be 1 minus d. Okay, again we are working with compound interest, compound discount only. Okay, right now. Okay, so this is what we'll have. V is nothing but 1 minus d. We also know that this is equal to 1 by accumulation factor 0 comma 1. They are reciprocals. These two are reciprocals of each other. Okay, so that can be written as 1 by 1 plus I. So V can be written as 1 minus d, or it can be written as 1 by 1 plus I. Both are correct. This becomes your formula. So if I is given, we'll use 1 upon 1 plus I. If d is given, we'll use 1 minus d. This becomes our discount rate for 1 year. As I said, we'll use the symbol lot later. Let me make a question. So an investor invests 5,000 in an account paying 6.5% per annum discount rate. Find the accumulated value after 7 years. First is directly using the discount rate, and second is using the equivalent interest rate. Okay. So in the first part, we'll directly say D is 6.5% per annum. And we are finding the future value, the accumulated value. Okay, so that means we'll have to divide by the discounting factor. If you don't remember, I'll be making a small table later on for you to remember. Okay. So right now, say future value at time, what time? 7 years. 7 will be equal to present value upon 1 minus D raised to 7. Okay. So the future value would be 8003.662. And the second part, we are saying using the equivalent interest rate. That means we'll convert our rate of discount into interest rate first and then calculate the future value. This is the formula. Okay, now we'll use that when we are calculating future value. So present value into 1 plus I raised to 7. Whatever. 69519. You can see it's the exact same answer. If you have slight difference, that might just be because of the number of decimal places that we have taken. Okay, so if we would have taken all decimal places for this rate of interest, 10 decimal places, 12 decimal places, then this would have been exactly same. But we don't want to go into that much accuracy. Okay, so this much is fine. Okay, so it's basically the same answer, because These are the same rates of interest. Okay, rates of interest and rates of discount. These are called as equivalent rates. So equivalent rates are nothing but the rates that gives the same returns for the same time period. So like here we are saying for the same time period of 7 years, the returns on 5000 was 8003.66, and here also for the 7 years the return on 5000 was 8003 point, nearly the same 677, right? So they are giving us the same returns. So that means these two rates, D being 6.5% and I being 6.9519%, they are equivalent rates. They are not equal. Clearly 6.95 is not equal to 6.5. They are not equal, they are equivalent. So if they give me the same returns, or you may say if they give me the same cash flows for the same time period, then they will be called as equivalent rates. Okay. Sambhav, did you say something, because I could not hear you?
No.
Okay. Effective rate of interest. We say the amount of interest earned at the end of the time period, represented as a proportion of initial amount, is called as an effective rate of interest for that time period. This is just a definition of effective rate of interest. Now the time period that we have been taking from throughout this was 1 year. Okay, 1 year was the time period. Of course, whenever we were talking about 5 years, 10 years, they were all multiples of that 1 year, because our interest was compounding every year. That is why that time period that we were talking about is 1 year. Now in the next chapter we'll see that the time period could be smaller than 1 year, time period could be greater than 1 year. That is why this definition is according to time period, not end of the year. Okay. Now if I give you a simple example, let's say you come to me and ask for a loan. You ask for a loan of 100 rupees. I say, okay, for every 100 rupees that I give you, I will charge you interest of 10 rupees. Okay. So the interest that I am charging you is 10 rupees. Okay. For every 100 rupees that I am giving you, I am charging you interest of 10 rupees. So how much will you return at the end of 1 year? You will return 110, right? And we are going to say that the rate of interest, effective rate of interest, is the interest charged divided by or represented as a proportion of the initial amount. This is the initial amount, 100. So that is 10%. Rate of interest is 10%. That's very logical. Right. Now we are going to write effective rate of discount. Now I will just copy this and do changes on this so that we can understand what changes are we making. I'll write it with red. So you can see the changes. We are still talking about the amount of interest earned. But instead of the end of the time period, now we are saying the interest is earned at the beginning of the time period or the start of the time period. And then we are representing it as the proportion of the final amount. Okay. Now what is happening is, because in rate of interest we start from here and we go in this direction to find the future value. So you'll say we know the present value and we are trying to find future value. That is how the interest rate was created. But discount rate was created exactly opposite. We said we are going from this to this. We are coming back in time to find the present value. Therefore, the definition is also created in such a way that we are saying the interest is paid at the start of the time period, because we are coming back. Okay. And we know the final amount, so we will calculate the rate of discount as a proportion of the final amount. Okay. Let's say, I'll give you a simple example. Let's say again you want to you need 100 rupees as loan, and I again say that I will charge you interest of rupees 10 on every 100 rupees that I give you, but you need to pay the interest at the start of this year. You have to pay the interest right now. When you take money from me, you will have to pay the interest now. In such case, you will say, okay, I need 100 rupees. I will be paying interest of 10 rupees to you. So, okay, give me 110 rupees. Okay. And deduct the interest right now. So, what happens is, loan I will give you of 110. I will deduct the interest of 10 rupees. And finally, I will give you the amount of 100 rupees. So I gave you actually 100 rupees, but the loan that I am saying is 110. Okay, so the cash flow that I gave you is 100 rupees, but the loan is of 110. Can you tell me how much will you return me after 1 year? How much money will you return after 1 year? Don't be shy. Always answer. Even if it is correct, even if it is wrong, does not matter. Just have an answer. It's very important for you to have an answer.
100 rupees.
100 rupees. Okay. So 100 will be returned. Why? Because interest was paid at the beginning of the year, right? Correct? So then we should not be paying interest here. Perfect. No problem. But the 100 is not the loan amount. How much is the loan amount?
110.
Loan amount is 110. So I will say return me the loan amount. So you will be returning me 110. You will be returning the loan amount without interest. I have already charged you interest at the beginning of the year. Okay. You are just returning me the loan amount. Okay. But if you see the cash flow, here the cash flow is 100 and 110. Similarly here the cash flow is again 100 and 110. The cash flow has not changed. So the rate of discount that we will get, D that we will get here, that is the interest upon the final amount. Final amount is this 110. So that becomes actually 9.09091%. It will be 0909 recurring forever. These two are giving me the same cash flows. 9.0909% rate of discount and 10% rate of interest are giving me exactly the same cash flows. That means they are equivalent rates. So I is equals to 10% and D is equals to 9.0909% is are equivalent rates. They give me the same cash flows here and here. For any time period, I have just calculated for 1 year. If you are using this as compound rates, then for any time period you can find that the cash flows will be exactly same. These are equivalent rates. I hope the definitions of effective rate of discount and effective rate of interest is clear. So right now we have just kept the time period as 1 year. In the next chapter we will be taking the time periods different as well. Okay. So for today we'll end the class here. If you have any questions, let me know.
सर इफेक्टिव रेट ऑफ इंटरेस्ट में क्या होगा? अपन इंटरेस्ट एंड में पे करेंगे.
See, actual में what is happening here is you are paying interest here 10 rupees extra, right? Even here you are paying 10 rupees extra here, correct? You got 100 rupees, you paid 10 rupees extra here. So in both cases you are actually paying the extra amount at the end of the year. When I say I am deducting the interest at the beginning of the year, that is just conceptual. Okay, it's just conceptual because as I said, in rate of discount we are assuming we are going back in time. Okay, that's the concept, nothing else. So actual mein the cash flow has not changed. So next week this is our second demo lecture. Okay, so next week we will have our regular lectures. We'll start our classes. Okay, so days we are a little bit flexible. If you have a problem with a particular day, whichever we say, we can shift it one day here and there. Okay, but it will be informed to you by the management staff. Okay, timing we are going to keep 6:30 to 8:30. Okay, it will be in weekdays. Which days will be informed to you. Okay, so at the beginning we will have 2 days, and after maybe 2 months or so we will be starting a third day as well. Especially for Excel, we will be starting lectures on the third day. Okay, so if you like my demo lectures, you can join our classes. You can call the number below, right? Okay. Thank you for all the emojis that you are putting in. Okay, chalo. So if you have any other doubts, you can always call the number and you can ask. Okay, chalo. Let's end the class here. Okay, chalo.
Sir,
Yes.
sir, is this is the last demo class?
Yes, this is going to be the last demo class. See, if you are still not sure, you can call down there and ask for one more demo class or so. In the regular lecture we will send you the link and stuff. Okay, you can attend one more demo lecture. Okay, but generally we give 2 demo lectures. Okay, if you feel next week also you want one more demo lecture, you can join. Okay, you just have to ask the Deepak sir is most likely going to pick up the calls. Okay, you can see the number below. Okay,
Okay.
sure. Let's end the class here. We'll meet next week. Bye.